we've successfully penetrated every technical conference that we've gone to. He sent an email or a message to everyone at the conference, like, "Hey, come check out our demo." And the conference organizer was like, "Wait, how did you do that? We didn't give you permission to do that. You didn't pay us to do that. How'd you do that?" It's like, well, it's because your APIs are wide open. I connect as an authenticated user, and all it's doing is checking the authentication, and then it's saying, "Hey, because you're an authenticated user, you can call whatever you want on the back end." So we did.
What was the conference about? It wasn't like a cybersecurity conference at all, was it?
This was a cybersecurity
Oh
conference.
god! Oh god!
Brilliant.
Hello and welcome to That Tech Show, the show that reveals the magicians behind the magic that is everyday technology. Now, I'm flying solo this week. You're stuck with me. Chris has somehow managed to overheat his router, so he's having internet troubles, and therefore we can't record these introductions as we normally would. That being said, let's cut right to the chase. This week, we have Rob Dickinson join us on the show, where we delve into the world of geekery and nostalgia, as well as API security. So having Rob from Resurface on the show was a delight. We get all nostalgic talking about retro console gaming and hacking Atari and Commodore 64. Do you remember those? We talk about database development with dBase 4, infrastructure. Now that's pre-cloud infrastructure for all you newbies. All wrapped up in a neat little jacket of cybersecurity and entrepreneurship. So there's Rob Dickinson. I hope you're having a great week, and I hope you're looking forward to the Platinum Jubilee. That's a 4-day weekend. And I'll catch up with you after the show. Here is Rob Dickinson.
Well, hi, my name is Rob Dickinson. I'm founder and CTO at Resurface Labs, and great to be with you here this morning. Part of introducing myself, I'm an old school geek, self-taught programmer. Started when I was a kid, put myself through college doing programming. Worked for some big companies like Dell and Intel, and back out on the startup circuit now with Resurface, and really having a ball helping folks with their cybersecurity. And we're really specifying, or we're really specializing around API security, which really is the doorway to just an amazing set of topics that we're grappling with. Not just technical, but also legal, privacy, ethics. A lot of things really come to a sharp point when we're talking about APIs and these digital transformations around those APIs. So it's a really fun time to be in tech, fun time to be in cybersecurity. And again, thanks for having me on the program.
Thank you for joining us. It's really good to have you. I mean, aside from kind of Resurface Labs, there's a whole lot of stuff to get into there with Dell and Intel. But you said as a kid, you were coding. What age are we talking about here?
I got started coding when I was 8. I'm dating myself a little bit, but when I was 8, I really wanted an Atari for Christmas, because that was the big game platform at the time.
Do you know, I'm really missed out on Atari. Did you do Atari, Sam?
I was Commodore 64.
No, I wasn't that early.
Right, so that's what I got instead. My dad just had no part of the Atari thing. He was like, if you want to play games, you should write the games first. And that was kind of his opinion. So I got a Commodore 64 and a subscription to PC Magazine, which at the time, you get the magazine, it would have a disc in it, and that would be the compiler, and they would have the program listings would be printed out in the magazine, right? And so you would type in the program listing, and that's how you would play games, right, on the C64. So that's how I got started.
That's cool. Like, I remember, I mean, I did not program on my Commodore 64. I'll just say it right there. But I remember it was on cassettes, like not CDs or floppy disks. It was like a tape, as you would expect music. And that really didn't click how bizarre and crazy that is. And I remember Granny's Garden, and I also could take the cartridges in the back as well. So I remember having Terminator 2 on it, but never did the programming thing. So I don't. What language is that?
Oh, it was a lot of BASIC but I also really got into C64 assembly for whatever reason. So I did quite a bit with that.
That's really cool. Did you build anything of note with this, or was it just following the tutorials on the PC Magazine?
It's funny. I guess I can admit this now because the statute of limitations is probably passed. But what I got really into was removing copy protection from software. So at the time, there were all these different tricks that, because I was a kid, I didn't have any money, and I was growing up in Florida, and we just didn't have access to a lot of tech there. And so there were all these games that I wanted to play, and a lot of them were copy protected. And the game developers would use all these fancy tricks. They would hide data kind of on the boundary between sectors of the disk, and they do all these special things to hide the activation codes. And I got really really good at being able to take stuff and decompile it and find those things to be able to turn the copy protection off. And then one day my dad brought home from work a set of disks that had been infected with the Jerusalem B virus, which was one of the first really prolific, computer-based viruses. And what was amazing about that is that they actually got that infection from a piece of commercial software. So the actual software house that produced the disks and master duplicated all the disks had actually been infected with Jerusalem B themselves.
Intentionally or by accident? Like,
No, just it had just spread. It just spread. Because it was a virus that would spread from machine to machine through infected any kind of infected disk.
I'm just looking this up. This is in the end of October. Well, October '87.
Yeah, it was one of the first like worldwide viruses. And so actually my dad and I spent quite a bit of time, pulling that apart and looking at how it worked. And, it's amazing, amazing piece of technology. And that was kind of the first thing that got me interested in security and cybersecurity, because that's when it kind of shifted from like, it's not just limited to taking software and kind of using it outside what the original developers intended, removing copy protection or removing license limits or things like that, but that you could actually use software to, intentionally inflict damage on someone. And that just, really opened my eyes to kind of the dark side there a bit.
How did you go about sort of taking that apart and seeing how it was actually created?
The same way that we did all the software that we did. So I had modified my Commodore 64. I put a hardware switch in that would throw a debug interrupt. So you could run it, let it get to a certain point, and then hit the switch on top and get a debug interrupt fire and get a dump of all the registers and get a dump of what the machine was doing. And you just kept doing that. And so you could profile kind of what the application was trying to do.
So, how old were you when you're doing this?
I was in junior high school at that point, high school.
So, what age does that translate to for us UK folks? Because we have different school ages, don't we?
Yeah, I was 14, 15.
So that's pretty advanced stuff for a 14 or 15-year-old, like hardware debugging. I mean, is some of this led by your father?
Yeah, I just like computers just always kind of made sense to me. I mean, I just always felt like I could play. I'm a failed musician as well. I think there's so much crossover between music and computers. I mean, they're both cases where you have this thing and you're trying to get some kind of tune out of it, and it's a collaboration between you and the instrument.
Yeah, I think a lot of people have that. I mean, Sam and I have that as well, really.
But I would not have made that. I'm musical. I wouldn't say I'm a musician. I'm musical, but I wouldn't make that commonality between those two things. It's really interesting how you describe it like that. It's a very technical way of looking at music, whereas I'm just like, oh, I'll just stick my fingers down and just strum a few chords and see what happens, sort of thing. you know.
I think it's really interesting the way that you got into some of that early on, because I mean, I always had computers around the house. My dad always used to build computers, and so I'm used to taking things apart and building stuff, but never really got into the software side of things until I was at university. I was always jealous of my cousin who was writing software and silly little computer games that he'd built, or in fact the virus that he wrote for his university or for his college even. Which was quite entertaining, that deleted the startup folder and turned every machine off in the college. Why not? If you can do it, dropping him in it a little bit there, maybe. But I think it's really interesting the approach that you take then. So when you went away to university, then was that with an intention of like, I'm going to carry on with computing, or did you go an entirely different route to get into software development?
No, it's funny. So at the time, there really was no expectation that you could make a living doing software, or that it certainly wasn't a very mainstream thing. Ironically, the same thing about that you could say about music, right? Like, yes, there are people that make a lot of money doing it, but most people don't. That are in the field, and so it very much had that feeling to it. All the money was in the hardware, and so the software in a lot of cases was given away. It just wasn't really the focus, right? And so that was kind of the dominant thinking at the time, was like, if you're going to go into computers, that's great, but don't do software, do hardware. That's where all the money is. And so I actually went to school for electrical engineering with a digital design specialty, which is kind of as close as I could get at the time to computer engineering. But most of my schooling was actually spent on the hardware side. And again, it's just, sometimes you just fall into these things. I needed money, just trying to pay my bills, broke college student. And I started doing database development professionally on the side as just a way to pay my bills. And by the time I got to graduation, it was pretty obvious. It was like, wow, I can make more money doing this than I can using my actual degree. So the good footnote though there is I did ultimately end up at Intel, and my hardware studies and my degree actually did come in very, very handy in that context. But it was kind of amazing just to realize, that you kind of gotten to that point, and I could kind of take my own path there. So it was super fun.
Is that what you were queuing yourself up for, though, doing that degree, to actually go into somewhere like Intel?
I'd love to say that it was that intentional, because it would make me sound really smart, but I think at the time, I wasn't really sure what I wanted to do, and how I kind of approached that was, well, I'm not exactly sure what I want to do, so I'll try to do the engineering road. Like, I'll try to do like the hardest thing that I could think of to do, and challenge myself and stretch myself. And I just figured, even if I didn't ultimately want to do engineering, like, I would learn, I would it would lead me to kind of the next thing. So yeah, like I said, I'd love to say that it was that intentional, but sometimes you just roll the dice and see how things go.
Well, I think a lot of the time going away to university is a way that you figure out that you hate your degree and you want to do something entirely different. I mean, that certainly happened for me, and I ultimately came back around to using my degree. I think that's one of those things. So this is what, mid-90s now, I guess, that you're graduating?
Yeah, I graduated mid-90s.
How does one find a database design job whilst they're studying at university in the mid-90s? Where on earth did you come across that?
So again, I kind of fell into it. Luck and chance plays such a huge role in our lives. So again, I needed money. I was a broke college student, and I applied at this phosphate fertilizer manufacturing company in Zephyr Hills, Florida, for a summer internship. And it was so funny because I go to this interview, and so we're supposed to have these interviews on a Saturday morning. So I show up on the Saturday morning, and I'm in jeans and like a polo shirt, and I've got my hard hat, and I've got my steel-toed boots, Like, because I'm like figuring like, well, it's a manufacturing plant, right? And I walk in the front door, and everyone there is in a suit and tie. And I'm just like, I'm so mortified and embarrassed. Like, it just honestly didn't occur to me. I've never been on a job interview before. I mean, maybe in high school, but like, never something that I really cared about. And so I, very sheepishly, go and sit in the back, and the general manager of the plant comes in, and he gives this, little introductory speech, thanks for coming. This is what we'll be doing this summer. And he looks around the room and he's like, okay, so stand up if you have safety glasses and steel-toed boots, and you're ready to walk into the plant today. And me and this other girl were the only two people that stood up. And he said, great, you're hired. Everyone else, thanks for coming.
Huh.
Oh,
Wow.
there you go.
Serendipitous.
So I ended up working in the lab doing quality analysis. So we would be sampling the phosphoric acid vats and the sulfuric acid vats, and taking samples off, air samples off for ammonia monitoring, and other kinds of environmental monitoring. And we had this really, really awful software package. It was for dBase 3. So again, dating myself. dBase 3. So you have to put all your environmental data into this program, and so sit there and rebuild its indexes for hours and hours and hours on the machine. And at one point I went to my boss and I said, hey, this software that we're using, this is garbage. I mean, I can't believe this is what you do. This is what we're supposed to use all the time. I could do something better than this in a couple weeks. And she said, great, do it.
Hmm.
And so I basically took that software package and I rewrote it in dBase 4, which is the best thing ever, because dBase 4 had maintained indexes and you didn't have to have the machine check out and go to lunch. And so that's what I did. And so that was my first kind of foray into development. And then I kept that project going, and ultimately hired a salesperson and sold that software to a couple of the other fertilizer complexes in the area. So that was my first kind of playing around with creating something from scratch. But again, it's all accidental. It's all kind of seeing an opportunity and going after it.
It's funny how these things happen, but I mean, that's not just a foray into software development. That's a foray into entrepreneurship, isn't it?
Yeah, it was fun.
So that's probably setting you up pretty well then to head into the .com boom then. So where do you go from an inspired fertilizer software program after that?
So I thought for sure, my goal was really to go to Silicon Valley, because that's where it's at, and there just weren't enough opportunities in Florida or the Southeast. And I just happened to get a job offer in Colorado Springs, in Colorado here. And I pulled, and they were willing to pay my moving expenses. And so I pulled out the map, and I was like, well, it's like 2/3 of the way to the valley. So I'll just do that as the first step. And I'll go there for a couple of years, and I'll learn to ski, and I'll learn to snowboard, and then eventually um and the company that I worked with in Colorado Springs, it was a bunch of ex-Borland folks. So they were like, yeah, come out here and work with us for a while. And then, if you want to go to Borland or one of the other companies in the valley, like we'll help you, we'll help you do that. But ultimately ended up just staying here in Colorado.
So what led you through the .com boom then? What had you picked up when everything is taking off with the internet?
I had one of those, classic .com experiences where, you really didn't, nobody really knew how big it was going to be. I mean, there was this idea, right, of what the internet was going to be, but the technology wasn't really there at first. I mean, we were so limited by the hardware that was available to us at the time. And now, like, the limitations are really on the software side. But at the time, it was really, can you get enough money to build a big enough data center and have enough machines going and all of that stuff. And I was at a firm called Achieve.com. We were a classic .com startup, and we were developing an application that would help K through 12 schools really build a community online for students and teachers and parents to be able to collaborate. And it was really like, I mean, in modern terms, it was really like a social network for primary education. But we didn't really have the language for that yet. I mean, we're just making all this stuff up as we went along, and had that experience where we went from 0 to 2,000 schools in a very, very short period of time. It was 4 or 5 months, and scaled up to 400,000 plus customers or users in that same period of time. And it was really eye opening. I mean, there are very few endeavors in life where you can build a customer base that large that quickly. And it was all so new at the time, and it was just very, you could see there was going to be an obvious appeal around that approach.
So what sort of problems are you facing, doing this around the turn of the century? Seems terrible to phrase it like that, doesn't it?
I know, right? I think our biggest challenges were really around infrastructure. This is all pre-cloud. So you would have to build some kind of data center. You'd have to set up your own connectivity. You'd have to buy machines, you'd have to run the networks, you'd have to run the firewalls, you'd have to, you had to do everything.
Was there anything else to do with the scale, or was it literally how many people are hitting the small number of servers you had available?
No, it was scale too. We're signing up customers, watching our performance degrade. Trying to figure out like, well, how do you scale this thing? How do you redesign this? Very, very quickly, we went from kind of monolithic design to distributed design to thinking about horizontal scaling. You're reading like papers, like we were reading, papers that had been written by some of the early Google guys and like some of those folks. But none of this was like off the shelf stuff that you could just go out and grab. It was all do it yourself. It was all assemble yourself. So the budgets were really high, the timelines were really long, and it took just a tremendous amount of skill and expertise to even do something relatively simple. And it's so different today. And the other thing, like at the time, like the other thing that meant is that there's really a tremendous amount of gatekeeping around computing in the 90s, because like most people couldn't afford a Unix workstation. Like you'd go to a university lab and you could get that, but it's not like you would run Unix at home. I mean, you'd have to have something else at home. So you couldn't even necessarily get access to some of the core technologies that you really needed. And that's just what's so amazing about being in the field today. It's easy to get a Mac. It's easy to run Linux. It's easy to go to Azure or AWS and run whatever you want. Even if you've only have $5 to spend, you can get off on a journey. And one of the things that we've done with Resurface is we've really worked with a lot of engineers around the world, and we've really focused on younger engineers that aren't in tech hubs, kind of like how I was growing up, like kind of hungry for opportunities and not having a lot of local opportunities for that. And it's really amazing. I mean, if you have a laptop, a decent laptop, you can connect from anywhere and work from anywhere now. That's really the vision that I think we saw in the 90s, that really, this computing could be ubiquitous and could really open pockets of opportunity, all around the world.
Yeah, we'll get into the Resurface stuff in a lot more detail, I think, coming up. I'm just curious to sort of reflect on that as well, of how different it was in the 90s of actually trying to string stuff together. I mean, no Stack Overflow. Like, how do you develop without Stack Overflow? Like, you're going through, you're reading papers, but how do you know where to go to get the papers?
There, you really relied on your community. Just like music enthusiasts or film buffs, I had friends who were into independent film, and they were always like sharing, like, oh, you should be looking at this director, or you should be, or this is coming out, or whatever. And it was kind of the same thing with software. You'd recommend books, you'd recommend, lectures to look at, and papers to read, and really rely on those folks. And it was funny, and sometimes you would just get terribly, terribly, terribly stuck. And I remember having multiple times. There was one time I was having problems with a Microsoft product, and I literally, it was their help compiler of all things. And I called, and I was on their technical support, like, phone line that you would call in. That was like the only way to do it. Like, there was no, you can just email. And so I call in technical support, and I sat on technical support for 6 hours on hold, getting connected to one person, and then the next person, and then the next person, and then the next person, before I finally got connected with this engineer at Microsoft who had worked on the help compiler. And he was like, oh yeah, if you're trying to do, a help file that's more than a megabyte to compile in the end, you need this special build, and I'll send it to you. Like, give me your address, and I'll send you a disk.
Wow.
And he did. And so, you got a floppy disk in the mail from Microsoft, and it was like, oh my God, it was like the best day ever. Like, now I could finish that project and submit my invoice and get paid. But it was it was much more like being an investigative journalist or something like that than yeah, because no Stack Overflow, no Google.
It's a hell of a lot of commitment.
Yeah, gosh. With all these, I'm just conscious of where you started, which was obviously hacking away at Commodore 64 and stuff. Were you applying any of this cybersecurity stuff at this point, or were you kind of strictly like a software developer?
The security angle has changed so much, because at the time, you knew that there was the potential for being hacked or being probed, or being attacked or whatever. But especially when we started building, these first couple big web properties that I participated in, we knew that it could happen. We knew that it would happen eventually, but it was almost like a badge of honor. It was like, if you got attacked or you got hacked, it was kind of like, wow, somebody's really paying attention, and somebody must really, like, want what we've got, and all of that. And it was novel, it was dramatic, but it felt like, you must be doing something really right for that to happen. So naturally, you'd kind of kick the can down the road a little bit if you could. You would build something, and then you'd try to make it successful, and then you'd worry about security, at some point, right? And that's what's really changed to where we are now. Where we are now, and we've run these experiments ourselves. If you take any kind of endpoint, and you stand up a new, microservice or whatever it is on Azure or AWS or GCP, or on your own hardware, wherever, as soon as that endpoint is connected to the internet, it's going to be probed within minutes. There's going to be people banging on the door, and that level of attack is going to be sustained the entire time that thing is live. Those attackers will be coming in before you run your first ad, before you're showing up on Google, before you've booked your first customer. Those folks will already be there. And then the other thing that's a real mental reset for me is the number of customers that we talk to, where their attackers are now the majority of the traffic that they see. So it's not just some dramatic, novel, rare event. It's really, bread and butter, day in, day out. And the bad guys outweigh the good guys in a lot of these scenarios. And it's really hard to kind of sit with that idea. because it changes so many of our assumptions about how these systems work and how to monitor them, how to tell if they're working properly. It really puts a completely different spin on that. The same way that if you think about like going down to a local bank, a bank robbery is a relatively rare event. It's very dramatic, right? But how would you operate your bank differently if half the people that showed up to use the bank on a daily basis were there armed and ready to rob the place? You'd have to conduct business very differently in that kind of environment. So that's a lot of what I think we're grappling with now is these technologies are so successful, but unfortunately the history of all technology is runaway successes lead to unintended consequences and negative outcomes.
So I'm keen to breeze over then your time at Dell and Intel then. So if these sorts of attacks were a novelty back when you were at Quest Software, like what were you doing then at Dell, and when did your awareness, or when did it start to become a bit of a priority, cybersecurity becoming a more of an issue that you had to deal with?
Yeah, it's a great question. So at Quest, so we started a company here in Boulder. We ultimately sold that business to Quest, and we were the Gartner Magic Quadrant leading end user monitoring solution as part of Quest. And so what we were doing was web monitoring, and our goal, or our focus was really on quality. So our focus was really, these applications are very complicated. They can break in all kinds of different ways. You can have customers that are seeing SQL exceptions instead of seeing real web pages. We also saw a lot of cases where we would have failures in business logic, where the systems would seem to be working properly, but we're actually doing the wrong thing. For example, selling airline tickets for $5 instead of $5,000. So the system is working and working really well, like processing those $5 orders really fast.
Yeah,
right?
surprisingly, they're dealing with a real spike at the moment. Not sure why.
Right, exactly. And then word gets out, and everybody's coming in to take advantage of it. We just saw the complexity go through the roof. As we moved from kind of static websites and file sharing and things like that to actual web applications and people wanting to conduct business over the web. There's a huge need just to understand what's really going on with these applications. Are they working well in all of the conditions that we're hoping that they work in? And then how we got from kind of there to here is really just that the world has moved from web centric technology to API centric technology, and then just these attackers by volume are so ever present now that really now anytime you think about a quality problem, my API is slow or my API threw an exception. Well, there's a 50-50 chance. I mean, is it slow because that was a real customer and it had a real impact, or was that slow because an attacker was trying to do a denial of service and they're trying to figure out like what slows down your site the most, or your digital property the most? Really, like that knowledge that attackers may be dominating your traffic, it really changes everything how you think about error codes or error states or performance and quality. And then, of course, about half of the security problems that exist today are actually quality problems. They're misconfigurations or their misuse of the code. Failures of imagination in terms of how these systems might be used in a lot of cases. And so, yeah, it's just been just kind of follow the data points, right? The world went from websites to APIs, and then the dark web stuff got a lot more profitable than it's ever been, and that's really what's driving all this, right? I mean, all these attackers, they're programmers too, They take their jobs very seriously. They are learning and they are evolving and innovating very quickly. And certainly in some cases, they're even very well funded and highly organized. So it's a crazy, crazy landscape.
So as it, as it says on your website, detect and respond to API security threats in real time. Is this a competitive landscape, or is this something that you are sort of discovering, creating a market for?
We're certainly not the only API security company.
That's why I'm trying to get the angle on this. Like, where did you come at it from, and how does that competitive landscape work for you?
It's really been incredible. I mean, really, just even in the last 2 years. I mean, when we first started Resurface, a lot of the folks that we talked to, yeah, we would talk about API security, and they'd be like, "Well, I'm not even sure we have APIs." You'd be like, "Dude, I'm on your mobile app right now."
That's always a little concerning.
Yeah, right. I mean, part of the challenge here is it's difficult to get a handle around kind of the metaphor and kind of how much things have changed. Like the web, the first internet was kind of easier to get your head around because the first internet, the one that we built in the 90s and the early 2000s, that was built for people. That was built for file sharing. That's for cat pictures. That's for vacation videos. A lot of that was for humans, right? It was humans using web browsers to access websites and logging into Facebook that way. Pre-mobile apps. All that kind of stuff. And now we've moved to an internet that is really, the hub of our global commerce and is super important from a business operational standpoint. And the dominant model is not humans using browsers to access websites. The dominant model is now pieces of software talking to other pieces of software across the internet. And those software components talk to each other through APIs. So the APIs are basically like the phone calls between those software agents. But it's a fundamental shift in how we think about computing because it's not human centric. What we're doing instead is we're empowering all these software agents, whether those agents are mobile apps or AIs or whatever they are, but we're empowering these software programs to act on our behalf, make recommendations for us, do work for us, find things for us. And they are primarily interacting with other software agents, not humans on the other side. So it's a huge shift to get your head around, and it's really happened, almost overnight. Even a lot of the traditional web properties that we used to work with, they see almost no web traffic, compared to the traffic they get through their mobile apps or through the APIs that their partners and integrators use.
Yeah, that's a really nice way of putting it, and it's so true. You mentioned, that's obviously all about APIs then. So what led to your just focus on APIs? What made you choose that path to kind of lead the way with Resurface Labs?
Honestly, it's because it's the biggest opportunity. Some of the data that we've seen lately, Gartner estimates that 85% of web traffic that's business to business is now APIs versus traditional web traffic. We're also seeing all kinds of interest from government agencies and enterprises that you wouldn't typically think of as technology companies that want to be part of this API economy. They want to participate in this. A lot of folks, they're moving towards APIs because their suppliers want them to move towards APIs. They want to get, they want to improve their supply chains. The Biden administration in the U.S. has done a lot to kind of advance the kind of the standards of care around these, and there's going to be some great outcomes. So one of the things that's come out relatively recently is that healthcare data, personal healthcare data now, is going to be available through APIs, and it's even very explicit that by API, we don't mean that you go to a website and you download a PDF that a human has to read, that this has to be for machine to machine. And that's great. Like, that's amazing. I mean, that means that we'll be able to use that healthcare data in all kinds of different ways that really just weren't scalable or possible before. But, every time I hear something like that, as somebody that works in the industry, it's like, yay, that's really great. And, oh crap, like, that's, what does that mean when, when your data about all of your citizens leaks? I mean, it's only a matter of time, right? I mean, we've had credit reporting breaches already that have effectively exposed data about, 5/8 of Americans. So, but that's just income and demographic data. I mean, what happens when all of our healthcare data leaks too? We need to be paying a lot more attention to the potential misuses of these technologies. I mean, we're seeing attacks this year that we've never seen before. The present doesn't even look like the past, let alone does the present look like the future.
Do you think the de facto then for API security is still either non or under supported security rather than actual, protected APIs?
I know this is a self-serving comment to make as an API security vendor, but it is absolutely shocking the number of organizations that are providing public APIs that are really mission critical for their business, where they have paying customers using those APIs, and yet they have virtually no understanding of how those APIs are actually being used, when they're breaking, how often.
Without going into sort of selling the product right now, we can talk more about the product in a minute. But are there any quick tips for someone if they want to test their API and see if it is secure? Maybe they've not thought about it.
Yeah, a great way to start is, if you're not doing any kind of penetration testing or bug bounty program or anything like that, those kinds of programs are relatively easy to start up. And that's kind of the traditional way of looking at it. Is I'll hire a firm that will pretend to be an attacker from the outside, but someone who's not actually out to do damage. And then what we're trying to commoditize is the idea of monitoring inside the firewall. So you hope that your firewall is keeping out all those bad actors, but we know that they can't do that in every case. So what you really need is a very strong surveillance system inside the firewall that's helping you understand how your APIs are actually being used and where the problems are. So, for example, if you have an attack that's an obvious attack signature, and the system responds with customer PII, or the system responds with sensitive details about the system itself and how it works, that's going to be super bad. So having a basic security system that helps identify and tag those kinds of problems is hugely important moving forward.
Are you still finding that's a big issue at the moment? That these are still some of the basic things that people are getting wrong?
Yes, over and over and over and over and over again. Everyone understands that there are risks around security, but the kind of the easy thing to do is hide behind your firewall. To be perfectly frank, there's also like a bit of nationalism that creeps in here. Sometimes you hear people couch this as like, Well, we can look at the traffic coming from Russia and we can shut that off if we want to. And that is a real threat. But a lot of the attacks that we see are not, country of origin related. By the way, the Russians know that. So they use compromised machines in the US to attack machines in the US so that those attacks don't look like they're coming from overseas. There's also been a huge rise in insider attacks. And again, those can be highly organized. So I won't share names about the vendors, but we've heard stories about how, some of these very large tech companies, these criminal groups will find college students with gambling problems, drug problems, like however they can get their hooks into these kids, but these kids like basically have clean records, right? These kids graduate from school, they go to work in low-level IT positions at these large companies, and now you have an insider that is compromised that can help you attack that organization from the inside. And for every one of those people on the inside, you might have 20, 25 people on the outside helping them. So highly organized. And these people are incredibly hard to find. I mean, you're basically talking about running counterintelligence programs to find these people. So it's, again, these hackers. I mean, there is a whole dark industry around this, and it is very lucrative. That's why they're doing it, and they take their jobs extremely seriously, and they're very well thought out. Back in the day, you just port scan, like, and nobody, or be a script kiddie, and you didn't even have to really know how to write a script, like to stage that kind of attack. But that's really not the kind of thing that we're seeing now. Just as an example, so as part of the pandemic, right? I mean, we haven't been going to in-person conferences. We've been going to virtual conferences. So there's these virtual conference platforms that have sprung up all over the place. Well, we kind of can't help ourselves. Like when we go to an event like that, I mean, we poke at it. We've successfully penetrated every technical conference that we've gone to. We've done things like scraped the attendee list. We had a very large conference. One of our engineers was gonna be demoing at the conference. He's a young guy. He's super excited. It was his first professional conference and his first time ever demoing. And so he sent an email or a message to everyone at the conference, like, hey, come check out our demo. And the conference organizer was like, wait, how did you do that? We didn't give you permission to do that. You didn't pay us to do that. How'd you do that? And it's like, well, it's because your APIs are wide open. I connect as an authenticated user, and all it's doing is checking the authentication. And then it's saying, hey, because you're an authenticated user, you can call whatever you want on the back end. So we did.
What was the conference about? It wasn't like a cybersecurity conference at all, was it?
This was a cybersecurity conference.
Oh,
brilliant.
The hardest thing about being in cybersecurity is that you're bringing up bad news, and nobody likes to hear bad news, right? So we actually went back to these virtual conference platforms and said, hey, you've got a problem. Here's the script that we used to attack your platform. They don't even say thank you. It's like they're pissed. They're like, why did you hack our platform? It's like
it was there.
it was there. Like, what did you expect? We're developers. I mean, you're at a cybersecurity event. Like, what do you think was going to happen?
Yeah.
And especially, we've got more, there are more attacks. They are becoming more sophisticated. And obviously there's more and more devices connected to the internet as well, obviously. Is that something that you're expecting to create further security flaws, potentially, further impact on human life, let's say? How do you expect that to play out as we start getting more of these devices connected?
I think you can take what we've seen in the past, what we've seen in the physical world, and I think you can use those metaphors to extend. A lot of the things that we do are really looking at analogs in the physical world and then saying, in the virtual world, those same kinds of things will happen. It's just a matter of time. Let's take connected cars as an example. So if you have a car that's a connected car, that means that it's only a matter of time before somebody figures out how to control that car remotely. And in fact, we've talked to a couple of friends of our firm who are professional hackers who have done exactly that. They've been hired by law enforcement and have successfully compromised law enforcement vehicles when those vehicles are moving. And so that can be even applying emergency braking systems, right? So now you think about, you're watching a heist movie and you've got a getaway driver that's chasing the police, and you've got a hacker and that they're working with who is changing the traffic lights to green and shutting down the cop cars that are trying to follow them. And then look at that from the other side. So when you have connected cars, won't law enforcement actually ask for the ability to remotely disable a vehicle in motion? So now the cops that are chasing that getaway vehicle, can they just shut down that vehicle instead of having to chase it?
I mean, this sounds great to me. I feel like we're going to be having more Mustangs and things back in movies, because you're going to need an analog car to get away.
That's right. That's right.
But although it's not necessarily in this specific scenario, the word ethics pops into my head a little bit when we think about controlling things, for air quote good or bad. Like, where do you stand on that in terms of knowing, like, whose ethics wins in a decision there? Is it the hackers that choose to be the ones to change the traffic lights, or is it law enforcement agencies or whatever the ones deciding that we want to close that down? Like, I don't know, it just feels like it could get a bit messy there. Do you have any thoughts on ethics, basically?
Yes, it's wide open. And the other big vector there is there's certainly a much larger appetite for government to start to weigh in on these issues as well, and what are the proper standards of care there. I think something like GDPR was inevitable to try to establish some standards of care and some measures of protection, especially around the third party data sharing. This is very, very dear to our hearts, because for all of the API security companies that are out there today, Resurface is the only one that we know of where you actually own all of your data. We're not a third party multi-tenanted SaaS platform where we don't do security by you send all of your data to Resurface and we analyze it. We're collecting and analyzing that data locally. All that data remains under first party control. We think that at least some of our competitors will ultimately be ruled illegal in Europe, if not other places. In fact, I read this really shocking article from Gartner yesterday. They estimate, based on different sectors, they estimate up to 30% of vendors may fail due to not being able to adapt to the new privacy regulations that are coming out in the next 4 to 6 years. The handwriting is very much on the wall about this, and I think we've seen there's an oversharing of data problem, right? There's a lot of vendors that are just happy to take your data, happy to take your data for free. So you're paying with your data, you're paying with your privacy. And I think, to bootstrap to where we've gotten to, I mean, obviously that's important. But the thing to keep in mind is that you don't know who's going to own that vendor in the future. So you give all your data to this vendor, then that vendor gets purchased by a bigger company. Well, guess what? Now that data set is in the hands of that larger company, and we've seen that pattern. So, digital privacy, I think, is an aspect to digital security and cybersecurity that really cannot be overlooked, because all these APIs and all these digital systems depend on other APIs and digital systems. These supply chains are very long. And when you think about a very long supply chain where every link in the chain is vulnerable to insider attack or corporate takeover by some larger firm, that's going to be problematic. And we see real world examples of that coming up. I mean, this isn't just academic stuff that we're talking about here. I mean, this is something that makes the news almost every day.
So talking a little bit more about the product itself then. So what's the most unique thing about it and how it works? Because it looks like there's a number of different ways that I can actually get data into Resurface.
Yeah, the thing that we're really solving for is to manage the risk around your APIs. And that's really what we're solving for. We want to point you at areas of weakness and areas of risk in your API operations so that you know what to focus on in terms of making those API operations more robust. And that's just the common theme that we come across over and over and over again is, you have technical staff that want to do things better. You have a security org that wants to do things better, but they can't take an empirical approach. It's not easy to apply KPIs. It's not easy to measure how well you're doing. And that makes it hard to tell if you're moving in the right direction, if you're making things better or you're making things worse. And of course, we're in this environment where APIs are, like, as a business operator, these APIs are kind of springing up all around you, and you can't ignore them. And from a competitive perspective, again, we see a lot of folks gravitate towards, we'll buy a better firewall. We'll buy a firewall that uses AI, and that firewall will block attackers on the network faster, and we'll just hold everyone at bay that way. And it's just not realistic. Like, those attackers are going to get through. And the other thing is that when you think about managing those firewalls, you're managing how many false positives they generate, and there tends to be a low appetite for risk around that. We don't want to block a legitimate user thinking that they're an attacker. In fact, for a lot of organizations, that's a worse outcome than having an attack, because you'll always lose revenue if you're blocking a real user, right? So that's really what we're solving for with Resurface. You have these APIs, but when you don't really understand what they're doing and how they're being used, you are exposing yourself to multiple areas of risk, and that's ultimately damaging for your brand.
So by plugging Resurface in, then is it something that lights up straight away with what's going on with everything, or is there a certain amount of tuning that you've got to do to start getting the data you want to see?
So what's great about this is organizations like NIST and OWASP, which we follow very carefully, they've really set some great objective standards about what you should be protected against. And so we start with those definitions. We have to guide a lot on this. The product has to guide a lot on this, because just gathering all this data is not enough. I mean, you need to know what you should be paying attention to, and what the meaningful signals are. So OWASP, for example, they have a top 10 list of, these are the things that you should be doing for API security. One of those is continuous monitoring. So we're solving for that one, and that tends to be the least often included in the security profiles that people are security programs that people are running today. And then in Resurface, we have built-in rules that look for a lot of those OWASP top 10 kinds of issues. And that's as a starting point, just to get the ball rolling. Like, that's the basic stuff that everyone should be doing. And then we can easily go beyond that. We can look at any subset of the traffic, any segment of the traffic that you want to look at, and establish monitoring rules around. So we're very, very flexible. And we can do that without any kind of custom coding or custom development. It's very easy to describe what you want to find and let resurface tell you if that kind of issue recurs in the future.
Is it covering any level of performance, the load that's coming through the system as well?
Yes, performance is definitely an aspect of quality that is important to measure, and so we do that as part of this. Again, our outcome isn't just to drive performance itself, but it's to say, is the performance expected? Did it meet the business need, or is it a case where the user is trying to create performance problems for the org? Because that's the thing. Like as an engineer, if you think about, like, so there's a 50-50 shot. Like, so anytime you see a performance slowdown, well, did we do something wrong and there's a case where it's running slow, or is that a DOS attack that's intentionally trying to create performance problems? If you can't get to that context pretty quickly about what kind of user was it, what was the activity that led to that performance problem, you can easily have completely the wrong outcome from the business side. You don't want to optimize performance for your DOS attackers. Like, that just makes the problem worse, right? So you have to have some notion of the context of this, and that's very difficult to gain.
And that's the sort of thing that you're able to expose with Resurface then?
That's exactly what we're doing. Yeah. Another way to think about that is a lot of developers don't really see what the attackers are doing. The developers, you're working on your laptop, you're working in your QA environments, things are very sanitized. And as a developer, you think, well, it all works on my machine, and then the firewall protects us from everything. And then the security team, they're managing the firewall. They have that real sense of, well, there's false positives, there's false negatives, all that stuff. But the stuff that gets through, well, the application team will take care of that. And really, both sides of the organization think that maybe the other side has it solved, or or the other half of the org is going to take care of it. And it really needs to be both of those groups working together.
So how do we get started with Resurface if we want to give it a go?
We are the easy button for monitoring. We are Kubernetes and Docker native. We're cloud native from that perspective. So a lot of the folks that we're working with, they already have microservices that they're running on Azure, AWS, GCP, and so we have a one-click Helm install, and we can install Resurface next to those APIs and gather that data, and then start continuously scanning that traffic in those environments where your apps are already running. So for anybody who's already on a native Kubernetes stack, this is super easy and native to deploy. You don't need a DBA. You don't need a big data architect. You don't have to run Hadoop or Kafka or some of these enormous data architectures to actually solve the problem. That's really what we've put a lot of our focus into, is making this easy. So easy to get started.
And what do we need? A license or something?
Yeah, we have a download and go model. And so we also make it easy from that perspective. Very straightforward, predictable pricing model. Yeah. Our goal is really, with our previous company, we really did web monitoring for very, very large properties, some of the largest websites in the world. And our goal with Resurface is really to make that technology available to everyone. So regardless of your budget, even if you're a startup like us and you're doing your first couple APIs, this is affordable. Not just affordable, but much cheaper than to hire the API analyst that you're going to have a hard time hiring. Again, that's really the problem that we're working backwards from, is like, even if you know what you should be doing, you still have a lack of people to kind of help you help you put that in place. So we want to help provide some of that intelligence, make the analysts that you have better, and make the orgs better.
All right. Well, is there any final thoughts you want to add for us, Rob?
Yeah, just thanks for having me on the program. And it's such a great time to be in tech. It's such a great time to be in security. It's a great time to be in the field. And for anybody that's listening to this that wants to get into this field or is curious about how to get started, always love to have those conversations as much as talk about what Resurface the company can do.
Oh, of course. As a final thing, you were talking about Resurface earlier on and how to get kids involved. Did you say there was a particular initiative you were doing?
Yeah, one of the things that we've done is we have a number of open source components that we use. In fact, all of our data collection is done through open source components, and that's a great way to get started. And so, actually, a way that we've recruited engineers to our team is to go out and say, "Hey, we'll do paid open source contributions," and it's a great way for folks to come in and get involved. You basically get paid to build your resume, and you get paid to have something in your portfolio that you can show what you can do. And that's just been an amazing way to bring in talent that's really engaged, and also do that in a way that's really meaningful to give back. A lot of folks that are starting out, just like me, starting out, there's a lot of stress and anxiety around, how do I get that first opportunity? How do I get that first junior level position, or whatever that gets your foot in the door? Paid open source or even unpaid open source is really a great way, to build your portfolio and show what you can do. And that's been super fun for us to run that kind of program.
So where can people go to find out about that?
Oh, you can contact me directly. I mean, in our case, yeah, we're always, we put a note out on Twitter every now and again about it, but we're always looking for open source developers to join the team. And then, I'd say probably half of those folks in our case end up graduating to work on other projects in the company.
Great. It's been a pleasure talking to you, and especially sort of reminiscing about the late 1900s as well.
Late 1900s.
Absolutely.
All right. Well, thank you for joining us, Rob. It's been a pleasure to have you on.
Thanks again. Appreciate the opportunity to come on.
Rob really seems to know his stuff, and it was a real pleasure talking to him. So that really took me back, that episode. So next week, we welcome Daniela Paredes, who co-founded the Minority Report style design tool for virtual reality, Gravity Sketch. Now, I've used this app. It's a really fun app. It's the app I use to show off to my friends whenever I'm showing off my VR headset. It's a really cool design tool, and we got the opportunity to actually speak with the founders and dig into a little bit more about how it all came about and the kind of future of the product. Now, this episode is quite weird because I was spending a week, a business week inside of VR as much as I could. So I actually conducted this podcast in VR. That's probably maybe why you would hear my face banging on the microphone. But anyway, I won't ruin the surprises on that one. So make sure if you're interested in VR, product design and startups, make sure you tune into that one. So as usual, leave us a review on Apple and Podchaser. We really like those reviews. They go a long way. A 5-star review, no less, please. Thank you very much. Stay in contact with us over at Twitter, twitter.com/thattechshow_, I believe. We've reignited our Instagram as well. So if you prefer Instagram, if that's your way of communication, then do check us out on, I think it's again, thattechshow_. Or if old school, I mean, we're talking about the internet here, but if you're old school, do go on our website where we have a contact form, or you can email us at hello@thattech.show. So here we go. We actually learned that a shekel is actually an Israeli and Middle Eastern currency worth about 24p. And I don't think Buy Me a Coffee supports that amount. I think it's at least 4 shekels. I could be wrong. I'm not too sure. But chuck us a few shekels over at buymeacoffee.com/thattechshow. And you can do wonders to support the show because, of course, we do it out of love. So again, I'm sure you've had enough of me speaking right now. So I'll leave you to your days. Enjoy the rest of your week and we'll see you next week.